Good morning, students. In this session, I will discuss Unit 2 Mean Value Theorems. In that, the topic is Cauchy's Mean Value Theorem. Contents of Cauchy's Mean Value Theorem. Cauchy's Mean Value Theorem statement. Applications of Cauchy's Mean Value Theorem. Objective and outcome. The objective is Cauchy's Mean Value Theorem, and the outcome will be student get to understand the concept of Cauchy's mean value theorem and its applications. Statement of Cauchy's mean value theorem. If f from closed interval ab to r, g from closed interval ab to r be any two functions such that fg's are continuous on closed interval ab, fg's are differentiable on open interval ab, and g dash of x is not equal to 0 for all x belongs to open interval AB. Then there exists a point C lies in open interval AB such that f dash of C upon g dash of C is f of B minus f of A upon g of B minus g of A. It is the statement of Cauchy's mean value theorem. Here in Cauchy's mean value theorem we have to take two functions f and g. Both must and should be continuous and derivable on open interval AB. And g dash of x will be not equal to 0 for any x belongs to open interval AB. There exists at least one point C in open interval AB, and satisfying the condition f dash of C by g dash of C is f of B minus f of A by g of B minus g of A. In Lagrange's mean value theorem, we will have only one function, that is f of x. And we will have the formula in Lagrange's mean value theorem is f dash of C is f of B minus f of A by B minus A. But here we will have g dash of C is also, g dash of C is g of B minus g of A by B minus A. Just dividing f dash of C and g dash of C, that is f dash of C by g dash of C is f of B minus f of A by B minus A whole upon g of B minus g of A by B minus A. Clearly B minus A get cancelled. We will have f of B minus f of A by g of B minus g of A. It is the value of f dash of C by g dash of C. So it is the statement of Cauchy's mean value theorem. Now applications of Cauchy's mean value theorem. The problem is verify Cauchy's mean value theorem for the function f of x is x square plus 3 and g of x is x square plus 1 in closed interval 1, 3. So given two functions are there, both are polynomials in x. Clearly both the functions are continuous functions and also differentiable for all x. But here in particular both the functions are continuous in closed interval 1, 3 and which are differentiable or derivable in open interval 1, 3 because the derivatives are existed here in open interval 1, 3. The derivative of f of x is f dash of x, that is 2x. The derivative of g of x is g dash of x, that is 3x square. Clearly both the derivatives are existed and g dash of x is not equal to 0 for all x belongs to open interval 1, 3. In between 1, 3, if we take any value, clearly g dash of x is non-zero, that is g dash of x is not equal to 0. So hence f of x and g of x satisfies all the conditions of Cauchy's mean value theorem. By Cauchy's mean value theorem, there exists a point C which lies in open interval 1, 3 and satisfying the condition. The condition is f of 3 minus f of 1 by g of 3 minus g of 1 is f dash of c by g dash of c for some c belongs to open interval 1 3. Substituting all the above values and equating for c, that is c value is 13 by 6, writing it as a mixed fraction, we will have 2 1 by 6. Clearly this c value lies in open interval 1 and 3. So hence Cauchy's mean value theorem is clearly verified because there is exist at least one value of c which lies in open interval a comma b. Here a is 1 and b is 3. So c value lies in open interval 1 3. So clearly Cauchy's mean value theorem is verified. So once again, both the functions are continuous in closed interval 1 3. Both the functions are derivable in 1 3, open interval 1 3, and g dash of x is not equal to 0 for all x belongs to open interval 1 3. There exists at least one value of x, say c, in open interval 1 comma 3 and satisfying the equation, that is f of b minus f of a by g of b minus g of a is f dash of c upon g dash of c. Substituting all above values or substituting the values for f of 3, f of 1, g of 3, g of 1, f dash of c, g dash of c in this equation and computing for c, clearly the value of c is lies in open interval 1 3. Hence the Cauchy's mean value theorem is clearly verified. Another application, verify Cauchy's mean value theorem for the function f of x is a sin x and g of x is cos x in closed interval 0 pi by 2. So clearly given function, let it be f of x and g of x. So that f dash of x is sin x derivative cos x, g dash of x cos x derivative minus sin x. Clearly both the functions are continuous in closed interval 0 comma pi by 2 and differentiable in open interval 0 pi by 2, and g dash of x is minus sin x, clearly which is not equal to 0 in the given interval open interval 0 comma pi by 2. Hence all the three conditions of Cauchy's mean value theorem are clearly satisfied. Hence by Cauchy's mean value theorem there exists a point, say c, in open interval 0 comma pi by 2 such that f dash of c by g dash of c is f of b minus f of a by g of b minus g of a. Here a is a 0 and b is pi by 2, that is f of pi by 2 minus f of 0 by g of pi by 2 minus g of 0 is f dash of c by g dash of c, and here c belongs to open interval 0 pi by 2. Now substituting the values for f of pi by 2, f of 0, g of pi by 2, g of 0, f dash of c and g dash of c. So and substituting these values and computing for c. So here we will have negative cot c is equal to negative 1, minus minus get cancelled, cot c is 1. Now 1 can be replaced with cot pi by 4 and applying the cot inverse on both sides. So we will have c is pi by 4, pi by 4 value c is pi by 4 clearly lies in open interval 0 and pi by 2. So thus the Cauchy's mean value theorem is clearly verified because here c value is occurred in between 0 and pi by 2. So simple, just two functions are continuous, two functions are differentiable in open interval 0 comma pi by 2 and g dash of x is not equal to 0 for all x belongs to open interval 0 pi by 2. Then there exists a point c which lies in open interval 0 pi by 2 satisfying the condition, substituting the values, functional values and computing for c. Here c value clearly lies in the open interval 0 pi by 2. Hence the Cauchy's mean value theorem is clearly verified. Find the c values, Cauchy mean value theorem for both f of x and g of x in the interval closed interval 0 1. And f of x is x square, g of x is x in closed interval 2 comma 3. Verify Cauchy's mean value theorem for the same functions and in the given intervals. Students, you can do these problems same as proceeding as above. We will get c values If C value is existed in open intervals, then the Cauchy's mean value theorem is verified, otherwise not verified. Thank you. For any queries, doubts, clarifications, please contact mobile number and email address. Thank you.